In this tape, we will cover Pre-Calculus Final Review Part 1. The first problem, perform the indicated operations and simplify. X squared minus y squared over x squared minus xy divided by x plus y over 2x. First thing we do is we invert and multiply. Instead of dividing by this, we multiply by the reciprocal. Now we're going to factor each numerator and denominator completely and hope to be able to cancel out factors common to the numerator and denominator. X squared minus y squared, difference of two squares, it factors into x plus y times x minus y. Here we have a common factor in x, which we can pull out, leaving us with x minus y. And 2 times x, x plus y, are already factored as far as they can go. Now, we can cancel any factor common to the numerator and denominator, any numerator with any denominator. So, for example, we can divide numerator and denominator by x plus y, also by x minus y, and also divide numerator and denominator by x. That leaves us with, on top, only 2. And on the bottom, everything has been canceled. It's not a 0. That leaves us with a 1. Because when you divide by x, when you cancel the x's, you divide numerator and denominator by x, so it leaves you with a 1 here, really. In each case, a 1. So 2 over 1, or just 2, for our final answer. In example 2, combine into a single fraction and reduce to lowest terms. Four over x squared plus 2x plus x over x squared plus 3x plus 2. Now, in order to add fractions, they should have the same denominator. What we'd like to do is to build fractions equivalent to each of these having the same denominator, and we're going to do that by determining the LCD, the lowest common denominator for these two fractions. To do that, we factor each denominator completely. Here we have a common factor of x. And here there's no common factor, but we can write it as a product of two binomials. This factors into x plus 2 times x plus 1. We now take each factor the greatest number of times it appears in any one denominator. So the LCD would be x times x plus 2 times x plus 1. That is, we're going to build two fractions equivalent to these, each having the same denominator. And then we will be able to add the fractions since they will have the same denominator. And we're going to use the fundamental principle of fractions, which says you get an equivalent fraction if you multiply the numerator and the denominator of a fraction by the same non-zero quantity. And we ask ourselves, what was done to this denominator to get this denominator. We see that to go from here to here, we had to multiply the denominator by x plus 1. Therefore, we must multiply the numerator by x plus 1 as well. And then we ask ourselves, what do we multiply this denominator by to get this denominator? And we see that we have the x plus 2 and the x plus 1. We multiply the denominator by x. Therefore, we have to multiply the numerator by x as well. These fractions are equivalent to the original ones, but they have the same denominator. Therefore, we can add the fractions. We can by combining their numerators over the common denominator. Here we have 4x plus 4 plus x squared. It's 4 times x plus 1, and I just multiplied the 4 out. 4x plus 4 plus x squared combined over the same denominator. Now, it says, and reduced to lowest terms. And we've combined it into a single fraction. Now, in order to reduce to lowest terms, we have to see if any other factors can be canceled from the numerator and denominator. In the numerator, we have x squared plus 4x plus 4. The denominator is all factored. Okay, the numerator, we can factor further. We can write it as, there's no common factor, but we can write it as a product of two binomials, that is x plus 2 times x plus 2. And then we see that we can divide x, numerator and denominator, by x plus 2, leaving us with a final answer of x plus 2 over x times x plus 1. Here we have it now in lowest terms. You can leave the denominator like this or multiply it out once you see that there's nothing else in common that you could cancel out. In 3, we want to simplify each of the following and write the answer using positive exponents only. And in part A, we have this, x cubed y to the 7th to the minus 2 power over x to the 1/3 raised to the minus 9 power. Okay, the first thing we're going to do is to realize that if you have, say, ab to a power, product to a power, you can take each factor, raise it to that power. So it's like ab to the m is a to the m, b to the m. So we have x cubed to the minus 2 power, y to the 7th to the minus 2 power over x to the 1/3 to the minus 9 power. Now, whenever you have, so say x raised to a power, the whole thing raised to a power, you can multiply the powers together. X to the a to the b is x to the a times b. So we get x to the 3 times minus 2, or minus 6 power, y to the 7 times minus 2, or minus 14 power, over x to the 1/3 to the minus 9, that is x to the minus 9/3, or x to the minus 3 power. Now we can break this up. We can make it this times this. When you divide, okay, and you have the same base, you can subtract the powers. So it's x to the minus 6 minus a minus 3 power, y to the minus 14 power, giving us minus 6 minus a minus 3 is minus 6 plus 3, or minus 3. So we have x to the minus 3, y to the minus 14 power. And it says, write your answer using positive exponents only. We can write this as 1 over x cubed, y to the 14th. That is, x to the minus 3 is 1 over x to the 3rd power. And this is 1 over y to the 14th power, so it's 1 over x cubed times 1 over y to the 14th. You multiply the numerators, you get 1. You multiply the denominators, you get x cubed, y to the 14th. In part B of this problem, also we want to simplify and write the answer using positive exponents only. 32x raised to the 0 power, x to the minus 2/3 times x to the 11/3 minus x to the 5/3. Now, first thing, 32x to the 0 power is just 1. If it had been 32 times x to the 0, then x to the 0 would be 1 and this would be 32. But this is the whole thing to the 0 power. It's just 1. Now, here I'm going to distribute x to the minus 2/3 through the parentheses. So we have x to the minus 2/3 times x to the 11/3 minus x to the minus 2/3 times x to the 5/3. This is 1, and this is like a times b minus c. It's a times b minus a times c. Okay, and since this 1, it's just 1, but it's multiplying the whole thing, it really should be like that. A times b minus a times c, all preceded by the 1. Okay, we can just drop the 1 here because just 1 times something will be 1. When you're multiplying here, we're going to keep the base and we're going to add the powers. Minus 2/3 plus 11/3 here. Minus 2/3 plus 5/3. So this gives us x to the 9/3, take away x to the 3/3. 11/3 minus 2/3, that's 9/3. 5/3 minus 2/3 is 3/3, giving us a final answer of x cubed minus x to the 1, or just x. In problem 4, we want to evaluate the following. The cube root of minus 27 over 64, take away 8 to the minus 2/3 power. Now, it so happens this is a perfect cube. It's minus 3/4. If you check that, minus 3/4 times minus 3/4 times minus 3/4, minus 3 times minus 3 times minus 3 would give you minus 27. 4 times 4 times 4 gives you 64. So the cube root of minus 27/64 is minus 3/4. Since minus 3/4 cubed gives you minus 27 over 64. Take away now 8 to the minus 2/3, all right, is 1 over 8 to the 2/3. 3/4 take away now 8 to the 2/3 can be thought of as 8 to the 1/3 squared. 8 to the 1/3 squared would be 8 to the 2/3. So we have minus 3/4 minus 1 over, now this is really the cube root of 8 squared. So we have minus 3/4 minus, the cube root of 8 is 2. 2 squared is 4. So we have minus 1/4. The cube root of 8 is 2. 2 squared is 4. So minus 1/4 minus 3/4, that's minus 4/4, or minus 1. In 5, we want to express as a simple fraction reduced to lowest terms. One over x minus 1 over 3 divided by 1 over x squared minus 1 over 9. we have a complex fraction. They're fractions themselves in the numerator and the denominator. Now, there are two ways of handling this. One way would be to subtract these two fractions, combining over an LCD for the numerator of 3x, and to combine these two fractions, combining over an LCD of 9x squared, and then, of course, inverting and multiplying. The other way is to multiply by 1 in the form 9x squared over 9x squared. Now, I'm multiplying by 1. If I'm going to get an equivalent fraction, whatever I do to the numerator, I have to do to the denominator as well. So I'm multiplying by 9x squared over 9x squared. 9x squared chosen because it is the LCD for all of the little denominators here. The 3, the x, the 9, and the x squared. This will clear all the fractions, but you cannot say multiply the top by 3x and the bottom by the 9x squared. Whatever you do to the top, you have to do to the bottom as well. Now, if you do this using the distributive law, you get 1 over x times 9x squared minus 1/3 times 9x squared, 1 over x squared times 9x squared minus 1/9 times 9x squared. In other words, I multiplied each part here by the 9x squared. Okay, this gives us, here, x cancels, we get 9x, minus here, we can divide 3 into 9, leaves us with 3x squared here. And in the denominator here, the x squareds cancel, leaving us with 9. And here the 9's cancel, so we have 9 minus x squared. So we now have it as a simple fraction, and we want to reduce it to lowest terms. Okay, just one thing here. When you're doing it, don't make the mistake, for example, of, say, doing it in your head and, say, canceling the 9 out here and then having nothing to distribute here. First distribute the 9x squared throughout, and then do your cancellations. Okay. Now we're trying to reduce this to lowest terms. We'd like to factor the numerator and denominator completely. In the numerator, we have a common factor that we can pull out of 3x, leaving us with a 3 minus x here. Check this, we get 9x minus 3x squared. In the denominator, difference of two squares, we can write as 3 plus x times 3 minus x. We can now divide numerator and denominator by 3 minus x, giving us a final answer of 3x over 3 plus x, or 3x over x plus 3, but this is as far as we go. We cannot cancel the 3's or the x's because 3 and x are factors in the numerator, but they're terms in the denominator. They're not factors in the denominator, so this is as far as it goes. In 6, we want to rationalize each denominator and simplify. Nine over 3 plus the square root of 6 minus 18 over the square root of 6. Now, let me rewrite it. And in each part, I'll indicate how we rationalize the denominator. When you're dividing by only one term, okay, like when we have a radical here, we're going to multiply by 1 in the form square root of 6 over the square root of 6. The idea is to get rid of the radical in the denominator. If we do this, square root of 6 times the square root of 6 will just give us 6 here. Okay, here, however, if we tried the same thing, if we multiplied top and bottom by the square root of 6, we would not get rid of the square root in the denominator because we'd have to distribute the square root of 6. The square root of 6 times the square root of 6 would be okay, but then you'd have plus 3 to the square root of 6. So instead, we multiply by the conjugate of this term. If this you can think of as a plus b, we multiply by a minus b. That is, we multiply top and bottom by 3 minus the square root of 6. Once again, whatever we do to the numerator, we must also do to the denominator. We don't have to do the same thing here as we do here, but we do have to multiply this fraction top and bottom by the same thing, And for this fraction, whenever we multiply the top, we also have to multiply the bottom. Now on top we'll have 9 times 3 minus the square root of 6. And on the bottom, using FOIL, we'll have 3 times 3. First will give us 9. Now for outer we'll have minus 3 the square root of 6. And for inner we'll have plus 3 the square root of 6. They'll cancel out. And for last we'll have minus the square root of 6 times the square root of 6, so minus 6. Or think of this as a plus b times a minus b, giving us a squared minus b squared. That is 3 squared minus the square root of 6 squared. Okay, now I just multiplied out the bottom. I'm not multiplying out the top until I see what I get over here. Maybe there's something that I can simplify before I multiply out. Now over here, minus 18, the square root of 6, when you multiply the numerators. The square root of 6 times the square root of 6, of course, is just 6. Now, 9 minus 6 is just going to give us 3 here. Just trying to save a little space here. 9 minus 6, we had a squared minus b squared. 9 minus 6, I just wrote 3. Now, 3 goes into 9 3 times, and 6 goes into 18 3 times. So this leaves us with 3 times 3 minus the square root of 6 minus 3 the square root of 6. And what do we get? We get 3 times 3, that's 9, minus 3 the square root of 6, minus 3 the square root of 6. Distribute the 3. 3 times 3, that's 9, minus 3 the square root of 6, minus 3 the square root of 6, or 9 minus 6 the square root of 6. Okay, it's not 6 the square root of 12, okay? It's, if like you had 3 apples and 3 apples, you'd have 6 apples. Okay, so you have 3 of this and 3 of this, you have 6 of that, whatever that is. In this case, the square root of 6. In problem 7, we want to solve for x. (36 over x squared plus 3x plus 2 minus 1 equals 6 over x plus 1. We'd like to, when we have an equation involving fractions, we'd like to get the LCD, multiply both sides of the equation by the LCD, get rid of the fractions, and solve the resulting equation without fractions. To do that, we have to factor each denominator completely. This, of course, is just 1 over 1. And we see that the LCD is x plus 2 times x plus 1. So I'm going to multiply both sides of this equation by x plus 2 times x plus 1. We have 36 over x plus 2, x plus 1, which I'll multiply by x plus 2 times x plus 1. That's the first part. Minus 1, which I'll multiply by x plus 2 times x plus 1, equals 6 over x plus 1, which I'll multiply by x plus 2 times x plus 1. Now, here the x plus 2 and the x plus 1 cancel, leaves us with 36. Take away 1 times, let me multiply this out, x squared plus 3x plus 2 equals, here the x plus 1's cancel, 6 times x plus 2. So I get 36. Let's distribute the minus 1. Minus x squared minus 3x minus 2 equals, distributing the 6, 6x plus 12. Okay, 36 minus 2, that's 34. Minus x squared minus 3x equals 6x plus 12. What I'd like to do is, let's say, bring everything over to the right-hand side. I'm going to subtract 34 from both parts, add x squared to both parts, and add 3x to both parts. When you subtract 34, add x squared, and add 3x, you get 0 on the left. And on the right, we get x squared plus 9x, 6x, and 3x, minus, okay, 12 minus 34 gives us minus 22. Okay, now you could have brought it all over to either the left side or the right side. I prefer to have a positive coefficient for x squared, so I brought it all over to the right side. Of course, if you brought everything to the left side, you could then multiply both sides by minus 1. It would come out the same. So either way, I have x squared plus 9x minus 22 equals 0. And I'm now going to factor. It's a quadratic equation. I'm going to try to factor. There's no common factor, but I'm going to try to write this as the product of two binomials. Looking for two numbers which multiply to minus 22 and add to plus 9. And they are plus 11 and minus 2. They multiply to minus 22 and add to plus 9. So when you set each factor equal to 0, and you get two possible solutions. Okay. And you now, since it's a fractional equation where there are variables in the denominator, you must check. At least as far as making sure that it makes sense. You don't get division by 0. Okay, so I'm actually going to actually go through the entire check, but I just want to show you that when you plug in the minus 11 here in the original equation, you do not get division by 0. You get minus 11 plus 1, it's minus 10 here, and here you don't get division by 0 either. You can see it in the factored form, or you can actually plug it in here. You get 121 plus 2 minus 33, so it's not division by 0. Similarly, when you plug in x equals 2, this clearly does not give you 0, and this does not give you 0. Okay, from then on, you're just checking your arithmetic, but this much of the check must be performed to make sure there are no extraneous solutions here in the problem. Okay, so we must check, and if you do, both of them do work out, and you get two solutions to this problem. You must check on fractional equations where there are variables in the denominator, and also on, say, radical equations when you square both sides. Okay, both times there's a good chance you might introduce extraneous solutions into the problem, which are not solutions to the actual problem that you started with. Okay, in problem 8, we want to solve for x. Square root of 2x minus 3 plus 3 equals x. Now, you might be aware of the fact that you're supposed to square both sides when you have a radical like that, but the first thing to do, of course, is to isolate the radical. That is, subtract 3 from both sides of the equation. If you square both sides in the original form, you will still get a radical. You have to square again after isolating it. So the easiest thing is just to isolate the radical first. You subtract the 3 from both sides. Now square both sides. When you square the square root of 2x minus 3, you just get 2x minus 3. X minus 3 squared means x minus 3 times x minus 3. It's not just x squared minus 9 or anything like that. You actually have to multiply it out by FOIL, x squared minus 6x plus 9. Okay, let's subtract 2x from both sides of the equation and add 3 to both sides of the equation in an effort to get everything on one side and 0 on the other. Gives us x squared minus 8x plus 12. And I'm looking to factor this. I'm looking for two numbers which multiply to 12 and add to minus 8. And they are minus 6 and minus 2. If you check this, you get x squared minus 2x minus 6x is minus 8x plus 12, giving you two possible solutions. And they're only possible solutions because you actually must check. Now, you check in the original equation, not in the squared out equation. I'm assuming your arithmetic was all right and that this is really the solution to the squared equation. The question is it the solution to the original equation? So the square root of 2x minus 3 is the square root of 2 times 6 minus 3 plus 3 should be equal to x, which is 6. And the square root of 2x minus 3 plus 3 should be equal to x, where x equals 6. And I get 12 minus 3, that's 9. The square root of 9 plus 3 should be equal to 6. 3 plus 3 does equal 6. So x equals 6 is a solution. Now what about x equals 2? We go back to the original equation. The square root of 2x minus 3 is 2 times 2 minus 3 plus 3 should be equal to x, which is 2. The square root of 2x minus 3 plus 3 should be equal to x, where x equals 2. This gives me the square root of 4 minus 3. The square root of 1 plus 3 should be equal to 2. 1 plus 3, that's 4, is not equal to 2. X equals 2 is not a solution. So x equals 6 is the only answer to this problem. In 9, we want to solve for x. 6x plus 4 equals x squared, quadratic equation. Once again, we'd like to get everything on one side equal to 0, so subtracting 6x from both sides and subtracting 4. 0 is x squared minus 6x minus 4. And you could try to do it by factoring. It's our first inclination. We'd be looking for two integers which multiply to minus 4 and add to minus 6, and that's not going to work. So factoring doesn't work. We could try the quadratic formula. X squared minus 6x minus 4 equals 0. We match this up to ax squared plus bx plus c equals 0. And if we do that, then we know that the solutions can be found by using this formula. X equals minus b plus or minus the square root of b squared minus 4ac over 2a. So let's see. A is equal to 1. B equals minus 6. And C equals minus 4. Okay? A equals 1, B equals minus 6, C equals minus 4. So we substitute in x equals a minus b, that's minus a minus 6, plus or minus the square root of minus 6 squared minus 4. A is 1, C is minus 4 over 2a, 2 times 1. Let's see what we have. X equals minus a minus 6, that's plus 6, plus or minus the square root of minus 6 squared, that's 36. Minus times a minus is plus, it's plus 16 over 2. The minus of minus 6 was 6, plus or minus the square root of 36 plus 16 over 2. So we have 6 plus or minus the square root of 52 over 2. And if we want to put this in simplest radical form, we realize that the square root of 52 is the square root of 4 times the square root of 13. and that's 6 plus or minus 2 to the square root of 13 over 2. We can now on top factor out a 2, leaving us with 3 plus or minus the square root of 13 over 2. That's 6 plus or minus 2 to the square root of 13 over 2. We can now cancel the 2's, giving us as a final answer 3 plus or minus the square root of 13. That is 3 plus the square root of 13 and 3 minus the square root of 13. In problem 10, we want to solve for x and y. We have a system of equations. We have x squared plus y squared equals 10, and x minus y equals 2. Okay, we're going to solve this by solving the second equation, the one in the linear equation, in x and y, solving for either x or y and substituting for that value back into the original, to the top equation. So if we say solve the second equation for x, x equals y plus 2. Okay, by adding y to both sides, we're now going to take this value and substitute it back in there. X squared plus y squared equals 10 will now be y plus 2 squared plus y squared equals 10. We solve whichever is simpler, okay? So it's easier to, we want to solve for one of the equations for one of the variables. It's easier to solve the second equation. We solve it for x, x equals y plus 2. We then substitute back into the original into the top equation. X squared plus y squared equals 10. We now multiply this out. Y plus 2 squared is y plus 2 times y plus 2, y squared plus 4y plus 4, plus y squared equals 10, or 2y squared, y squared plus y squared, 2y squared plus 4y plus 4 equals 10. And to solve a quadratic equation, try to bring everything over on one side and 0 on the other. Gives us 2y squared plus 4y minus 6 equals 0. Y squared plus 4y minus 6 equals 0. We can then factor out a common factor of 2, leaving us with y squared plus 2y minus 3 equals 0. And this quadratic equation can be further factored. This quadratic expression can be further factored into two binomials. We're looking for two integers which multiply to minus 3 and add to plus 2. That's plus 3 and minus 1, giving us y squared minus y plus 3y plus 2y minus 3. Okay, this product is equal to 0. Each of the factors could be equal to 0. 2 can't be equal to 0, but y plus 3 could be equal to 0. Y minus 1 could be equal to 0, giving us y equals minus 3, y equals 1. We now go back to this equation here, x equals y plus 2. Since x equals y plus 2, we can figure out that if y equals minus 3, x equals minus 3 plus 2, x equals minus 1. So minus 3 goes with, y equals minus 3 goes with x equals minus 1. And here, if y equals 1, x equals 1 plus 2, x equals 3. These two go together. So we have two possible solutions. Minus 1 minus 3, x equals minus 1, y equals minus 3, and x equals 3, y equals 1 that we have to check. Obviously, they satisfy the condition that x minus y equals 2, the second condition, because that's how we got them. X minus y equals 2. Here it works. X minus y equals 2 works there. And x squared plus y squared has to be equal to 10. 1 plus 9 equals 10. 9 plus 1 equals 10. So they do check out. We have two solutions. I just want to show you the geometry of this problem for a moment here. What we had here was the equation of a circle with radius the square root of 10, which is a little over 3. And the line, this, remember I said, is a little over 3. That's a lot over 3. Okay, and here is a line when y equals 0, x equals 2. When x equals, if y equals 0, x equals 2. If x equals 0, y equals minus 2. One at the point 3, 1, and the other at the point minus 1, minus 3. Two places where the straight line intersected the circle. So that's the geometric interpretation of our problem. In problem 11, a similar setup. We want to solve for x and y. Now it's x squared minus y squared equals 9, and 2x plus y equals 6. Okay, we solve whichever equation is simpler. For x or y, whichever is simpler, I find it easiest to solve the second equation for y. So y equals 6 minus 2x, subtracting 2x from both sides. And having done that, I'm going to substitute that value into the first equation. That is x squared minus y squared equals 9. I'm now going to write for y what I found it to be equal to 6 minus 2x. X squared minus y squared equals 9. X squared minus, in parentheses, 6 minus 2x squared equals 9. X squared minus, now this means 6 minus 2x times 6 minus 2x. So to multiply out by FOIL, first we get 36. The outer is minus 12x. The inner is minus 12x. That's minus 24x. For the last, we get plus 4x squared. Now remember, it's x squared minus this. That means like a minus 1 has to be distributed through the parentheses. X squared